Hi, and welcome again to the next episode of Adventures in Automation. Last week we talked about how to prepare for an automation project, so this week it's time to crack on and look at starting our first example in the demo lab. Let's have a quick recap about just how we approach this. Okay, so as you'll recall, we have a 5-step process. First step, the problem statement. Work out exactly the scope of the issue that we're trying to resolve by building our project. Second step, break down the problem into its constituent parts. Understand how things are done now and how they need to be done better going forward. There may be parallel tasks going on, there may be interdependencies and prerequisites. Those are the things we need to understand. Next stage, now we're getting to the fun bit. Break the new process down into a flow. Understand where we start and where we end, where we need to branch, where we need to loop. Build a set of tasks that allow us to get from start to finish. Next step is to iteratively refine those tasks. So loop through them, drill down into them, get more detail so that we understand exactly how technically we're going to approach those tasks. Then, and only then, can we consider the last step. And that last step is to code. Is to look at APIs, is to understand how we're going to interact with equipment, how to test that our code does what it needs to do. Don't touch this until you've done all of these. Right, time for an example. First things first, the problem statement. So we've got our demo lab set up. It's separated out into a whole number of different sites, and those sites have devices from multiple vendors. What we want to do is ensure time is synchronized across the environment. Okay, we're going to focus on one particular site 1. The configuration that we're looking for is to have these two servers 10.0.10.10 and 10.0.10.15 configured and resilient across site 1, across the different vendor devices. Make sure that they're associated, they're reachable, and that time is synchronized on the devices with at least one of them. Okay, so nice clear problem statement, nice clear scope. And obviously quite a complex thing in that we've got multiple vendors to play with there, but let's see how we progress with that. So we'll look at the current workflow. How would we normally go about this? And it's something like this, right? You log into a device, you check its NTP config. If it's not correct, you fix it. You check its state. If it's not synced, you fix it. Pretty straightforward. Then obviously onto the next device, log into that and go again. So it's just that whole very simple hop by hop through the site. Just go through, fix them things as you go, but having to log into every device as you go, which is fine, right? When site 1 is 5 devices, when site 1 is 35 devices or 350 devices or 3,500 devices, then it gets a bit more tricky, and that's why we want to think about automating that. So, first step on that, once we've defined the current workflow, is to look at the flow of how we want the thing to work in our new automated project. This is the pseudocode, right? So we arrive at pseudocode being this flow, and really all it is a formalized version of the current workflow with all the bits ironed out that might cause you problems along the way. So here you can see there's a structure to this. There's a prerequisite task of preparing the inventory. There's a loop there that means you go through all of the devices in the inventory and you step through retrieving the config and state, checking the state, checking the config, and so on. So you're basically broken this down into a set of steps, loops, and conditional statements. But that's not enough to run, right? You can see that's a very generic statement of how that process will work. So what we want to do is go through this iterate and refine so that we're able to turn that into real code. It looks a bit like code, it's shaped a bit like code, and it's got a structure, which is the whole point. But now what we need to do is drill down into each of these things and get to a point where there are actually meaningful tasks associated with them. For example, prepare inventory of the devices. Well, how do you do that? You have to go away and to build this list of devices, but you need some extra information about them. You need to know what type of device they are, what their management IP is, what the credentials are that you access those devices with. And for those, you need to go away and use whatever your mechanisms are for managing those things, whether that's spreadsheets, your monitoring platform, whether you've got all that information in a CMDB. But that's what you need to do to go and fetch that data. Once you have that data, you then want to loop through those devices in the inventory and retrieve the config and the state that relate to the thing you want to change. So in our case, after checking the device type to find out what mechanism we need to use to get that information out, whether that's CLI or API, whether it's SSH or RESTconf or SNMP even. These are the sorts of things we need to do and what the commands need to be. We pull that information together and then we need to understand obviously what the output from those commands is and how that relates to the intent that we've expressed in our problem statement, because we need to be able to do checks, as we see, to make sure that the state is okay, to make sure that the config is okay. So we need those things in a fairly standard form so that we can tell, regardless of what device type they are, regardless of which vendor they are, that you're comparing the same state. Once we've done that comparison, once we've checked that the state is okay, if it is okay, great, we don't need to do anything more. If it's not okay, we need to check the config, and if the config isn't okay, we need to change it. And so this is, again, we need to define, right, okay, what is the device that we're trying to change? How do we make that change in terms of, again, CLI or API? What does the correct config look like on this device as opposed to that device? How do we push that config, and how do we check to make sure that we've actually pushed that config and the device has accepted the config? Not that it's had the right effect, but the fact that the config change has been made. Because then we have to retrieve the state again to check the effect of the change, and that's the same state retrieval that we've already looked at before. Now, if the state's okay, that's great, we're done and out. But if it's not, then obviously we've corrected the configuration, but there's a problem with the state, and so we have to then look at troubleshooting the connectivity. This is the bit where it gets a little bit grayer, because from an automation point of view, how do you go through a troubleshooting process? Well, typically you'll do one or two things here. You'll stop and you'll pass that information out to a manual process to go and do it, or you gather a load more information and try and point the engineer in the right direction in order to fix the issue. This is where it uses your experiences as a network engineer to understand, right, what can go wrong, and add some intelligence into the process. Essentially, though, the automation that we're looking at kind of stops at this point while that connectivity is fixed. And we can do one or two things. We can either break out of the process, or we can continue and just flag the error, as it mentions in the next step, so that it gives someone else the opportunity to go and say, all right, all of these devices are erroring, we'll need to go and fix them. When we got the go to next device thing there, the one thing that we do that we've not mentioned before is to log that success. Obviously, we want to be sure, we want to know where's it been successful or where's it failed, and how do I flag that up and report that out. So straightforward. Now, it's a little bit different when we're using IP Fabric, because what IP Fabric stops us from having to do is go fetching all this information directly from the devices. We're capturing all that information every time a snapshot's taken, every time a discovery is done. So why keep going back to the device when you've already got that data held centrally? For example, if we're preparing the inventory of the devices, we don't need to build that list from anywhere else, because we've already discovered that information in IP Fabric. We make an API call to the IP Fabric and we pull the inventory details from there. We can filter based on pretty much any attribute. We can filter based on the site quite easily. So that's a simple win there for the API calls. If we're retrieving the config and state of NTP, well, again, we don't need to do that. IP Fabric has already done that for us as part of its discovery. Okay, so with IP Fabric, we make an API call and pull the config and the state through from the API. Now, to correct the configuration, what we're not doing in IP Fabric is pushing changes back. So there's no change. We do things in exactly the same way we would have done it previously. But then when we come to retrieve the state again, what we can do is, rather than go in and logging into the device and pull in the state, we can trigger a refresh of the config and the state information into IP Fabric through an API call. Again, troubleshooting, connectivity. If we're going to pause the process for manual intervention, that's not going to change. We'll carry on and do things the same. However, what we can do is grab some of that information and go through that information gathering process using IP Fabric, because again, that information is already there through an API call. So we can pull that troubleshooting data through from there. The logging continues to be the same, no different. So you can see there the way the impact that IP Fabric has had on the process. Alternatively, what we might choose to do is not use the same process at all. If we've got a different type of information source, we can approach it in a completely different way. So for example, we've got IP Fabric and all of that state and configuration information already gathered. What we can actually do is build a compliance check within IP Fabric that every time the discovery is done, every time the data is captured, it automatically checks the state and the configuration and builds a report internally. We can build the compliance check in the web UI, or we can use an API call to build it if we should so choose. But essentially, once that's done, every time there's an update to the data, so that that report gets updated too. It's a very simple API call then to go and fetch that report for all of the Site 1 devices. And then what we do is we have a different kind of a loop. So using the data that we've already got, we can filter out devices, or we can put them into 3 lists. One where the state is all okay. So if we can already check, right, here's a list of all the devices where NTP is good, and we can just log those as okay and move on. We can then check all the ones where the config's incorrect and bring up a list, and then we can pass that list through to have the config corrected and fixed. No change. In that sense, that activity will still look the same. Then we can also have a further list of where state is not okay, where we can see there are issues, and again, we can use that information to go through into our troubleshooting process. Notice though that we've had one API call to retrieve all of this information in one go, and now all we're doing is just processing that. And then once those things are done, once we've logged the devices that are okay, once we've gone ahead and made our config corrections, and we've gone ahead and done our troubleshooting, we simply refresh the data through another API call. When we refresh the data, the compliance check report runs, and so we loop round for the next pass. Obviously, the structure to that is completely different, and the only way that we can have a structure like that is if we have a system like IP Fabric there ready to give us the data and pull the data through in the way we need it. Now we've got our workflow understood. Next time, we'll take a good look at how we go about extracting our inventory and NTP data from IP Fabric. Please like and comment on the video, subscribe to the channel, and click on the bell so that you don't miss future episodes. And join in the conversation with us on our Network to Code Slack and on our subreddit. And if you've any use cases you'd like me to take a look at, please feel free to drop me an email. Until our next adventure in automation, take care. See you soon.